Hello guys, welcome back to the channel. This video is the next episode of my Python learning journey. Today, we're going to dive into how Python operators work and explore the different types you can use in your code. In Python, we generally categorize operators into 7 types. Arithmetic operators, assignment operators, comparison operators, logical operators, identity and numbership operators. I've combined these two for simplicity. Bitwise operators. Each group has a unique syntax and purpose, which I'll explain throughout this video. First, we have arithmetic operators. These include basic mathematical symbols like plus, dash, asterisk, and slash, representing addition, subtraction, multiplication, and division. Beyond the basics, we have percent called modulus, double asterisk for exponentiation, double slash for floor division. The first 4 work exactly like standard math. However, the others have specific mechanics. Percent divides 2 numbers but returns only the remainder. Is used for exponential calculations, powers. Forward slash floor division works like normal division, but it rounds the result down to the nearest whole number and returns an integer, unlike the standard slash which always returns a float. For example, let's take 2 variables, first equals 32 and second equals 4. Let's run these print functions and see the results. But first, let's disable these 3 lines of code. You probably know you can comment out a single line with hashtag in Python, but if you want to comment out multiple lines, you can wrap the code block with triple quotes at both ends. After running the script, you'll see the results on the screen are exactly what we expect from basic math. But look closely at the division result. Even though 32 divided by 4 is exactly 8, Python returns 8.0. This is a key feature to remember. Standard division in Python always results in a float. Now, let's reactivate those 3 lines and deactivate the first 4. Rerun it. Notice what happens with modulus and floor division. If I divide 32 by 3, the floor division operator, double slash, chops off the decimal to give us exactly 10, while the modulus operator, percent, catches that remaining 2. Finally, our exponentiation takes our second variable, 4, to the power of 3, resulting in 64. Secondly, we have assignment operators, used to assign values to variables. The most common one is the equal symbol, equal sign. As we learned in the variables session, it takes the value on the right and assigns it to the variable on the left. However, Python also offers compound assignment operators. These are shortcuts that perform an arithmetic operation and an assignment in one single step. For example, instead of writing x equals x plus 8, you can simply write x plus equals 8. Both do the exact same thing. They take the current value of x, add 8, and update x with the new result. This logic applies to all others, dash equals, asterisk equals, forward slash equals, and even advanced ones like percent equals, forward slash equals, and equals. It makes your code much cleaner. Let's see it in action. Starting with x equals 10, x plus equals 5 gives us 15, and x asterisk equals 4 updates it to 60. Next are comparison operators. These compare 2 values and return a Boolean, meaning the result is always either true or false. We have 6 main operators. Equals equals, double equal checks if 2 values are equal. Exclamation point, equals, not equal to. Greater than sign, less than sign, equals, equals, greater than, less than, and they're equal to versions. These work just like math class. For example, if x equals 10 and y equals 20, x less than y is true. You can even use these to compare strings, like checking if a password input matches a stored one. As you see, it returns true because the input matches. If I change the input password, the result will be different. After that, we have logical operators. Think of these as links that combine multiple comparisons into complex logic. The 3 main operators are and returns true only if both sides are true, or returns true if at least one side is true. Not, the opposite button. It reverses the result, true becomes false. In a real-world scenario like a login system, you'd use and to check if both the username and password are correct. If I change username correct to false and rerun it, the result will be false because both sides of an AND operator must be true. Beyond simple checks, we can combine all three to handle very specific requirements. Look at this example, checking job eligibility. We have three variables, age equals 25, has underscore license equals true, and has underscore criminal underscore record equals false. To be eligible, the person must be an adult and have a license. We group this, age greater than or equal to 18 and has underscore license. Since both are true, this group becomes true. Next, we add in not has underscore criminal underscore record. We want people who do not have a record, so not false flips to true. When we run it, Python sees true, and the console prints true. This is how you create a brain for your program to make smart decisions. Next, we explore identity and membership operators. Identity operators is not check if two variables point to the same object in the computer's memory. Two variables might have the same value, but they aren't necessarily the same object. Here I have three lists. List X and Y have identical values. List Z is assigned to X. If you use equals, it returns true because the values are the same. But if you use is, it returns false because Python detects they are stored in different memory locations. However, Z as X returns true because they share the exact same location. Membership operators, in, not in, test if a value exists inside a sequence, like a string or a list. For example, I'll check if apple is in a list of fruits. Since it's there, it returns true. If I check for orange, it returns false. And if I check orange using not an operator, it will return true. You can also check if a letter is included in a string. Remember, Python is case sensitive, so you must match the casing exactly. Last, we have bitwise operators. These aren't common in everyday web scripts, but they are vital for low-level programming and cryptography. They work directly on bits, the zeros and ones. For example, Python sees the number 5 as binary 101. The main operators are AND, OR, XOR, NOT, and shifts. Let's look at an example, 60110 and 30011. Using int, AND. It only returns 1 if both bits are 1. The result is 0010, which is 2. With OR, it only needs 1 bit to be 1. So the result gives us 0111, which is 7. Next is the NOT operator. This one is unique because it only works on a single number. It flips every bit, changing zeros to ones and ones to zeros. In Python, this follows the 2's complement rule, so if you apply NOT to 6, the result is -7. Left shift pushes bits to the left, effectively doubling the value to 12. Right shift has it down to 3. Lastly, XOR stands for exclusive OR. It only returns 1 if the two bits are different. The result is 0101, which is 5. XOR is perfect for finding differences in binary data. Finally, Python has a specific priority for each operator, called operator precedence. Just like pandas in math, Python follows a strict order. In 10 plus 5 by 2, Python does the multiplication first, resulting in 20, not 30. The hierarchy is parentheses, always first. Exponents. Multiplication division modulus floor division. Addition/subtraction. Comparison identity membership. Logical operators, not and or. Always use parentheses to make your intentions clear. That's a wrap on Python operators. We've covered everything from basic math to complex bitwise logic. Understanding these tools is a huge step forward in mastering programming logic. If you found this video helpful, please give it a thumbs up and subscribe. What was the most confusing operator for you? Let me know in the comments. Thanks for watching, and I'll see you in the next one. Happy coding!